Here we see a couple of different gases together in this container. We know that the partial pressure of the diatomic one, this one here, is this much pressure. And we're trying to find the total pressure of all this. Well, we should be able to make a little formula out of this because we can see 3 of these diatomic molecules. We'll put them 3 of these D2s. And then we also see that there is 1, 2, 3, 4, 5 of those single ones. So we'll just call those 5As. And then we also see that there's also going to be 1, 2, 3, 4, 5, 6 of those ones. So we'll just put 6B. This is kind of like what's inside of there. And so if we had 3 moles of this thing, we would have 5 moles of this thing, and we would have 6 moles of that thing. So with that in mind, let's go ahead and see if we had this pressure right here, 0.87 atm. And that was the pressure of D2, right? Well, if we know that this is the pressure of D2, then all these are going to be basically relative to that by a fraction. So we would say, well, it would be 3 compared to 5, right, for the A. So let's figure out what that fraction would be for A. So 0.87 times 5 over 3. Because all this stuff is at the same sort of condition, so there's just going to be relative strengths, depending on how much there are. So there would be a 1.45 atm for the A, and then we would do the same type of multiplication, but 6 over 3. Let's just multiply that by 2. So 0.87 times 2 gives us 1.74 atm for B. Now, so now we kind of have the partial pressures of everything. Let's just go ahead and add them up. We'll go 0.87 plus 0.145 plus 1.74, and so we get the total of 4.06 atm in total.